Yeah, good evening, gentlemen and ladies. You are all welcome to night class. How is your weekend going? Hope it's going well. It's okay. In our last class, we are looking at Laplace of sine 80 before they took the light. So I'm going to continue from where we stop. I'll take it all over. Is that clear? Before we move further to consider piecewise functions. Please try and wake others to be part of the class because what we want to consider is very important, most especially in your forthcoming exam. So please, I want you to pay attention. Here we have another problem. Prove that Laplace of sine 80 equals to a all over x squared plus a squared. It's simple as ABC. Is that clear? Uh, your I strongly believe that you were taught hyperbolic functions in your ND. That is your year one calculus. I don't know whether you are taught hyperbolic functions. You know hyperbolic functions very well. I don't think this will be difficult. It's okay. So let's proceed. Let us write solution. We should prove that Laplace of sine 80 is equals to a all over s squared plus a squared. I want us to note that in hyperbolic function, let's write, note that sine 80 is the same thing as exponential I 80 minus exponential minus I 80 all over 2I. If you are taught hyperbolic functions properly. So take notes. Do you agree with me? Do you agree with me? Yeah. So far, so good. So far, so good. If you agree with me, it implies that instead of Laplace sine 80, we are going to write, and I want us to also know that when we have this is the same thing as exponential I 80 all over 2 minus exponential minus I 80 all over 2I. Sorry, two of us. Do you agree with me? So if you agree with me, this implies that let's define our Laplace transform. Laplace of f of t is equals to integral 0 to infinity, then exponential minus st, true of us, times what? F of t dt, right? Okay, so this is the function. So Laplace of exponential I 80 minus exponential minus I 80 all over 2I now be equals to integral 0 to infinity, amen, okay, exponential minus st times the function, which is what? Open bracket exponential I 80 minus exponential minus I 80 all over 2I close bracket the t. Do you agree with me? Look at the board. Do you agree with me? Oh, somebody said I should come again. Abdulaziz. I've not started solving. I'm just trying to break this down. I said in hyperbolic function, sine 80 is the same thing as exponential I80 minus exponential minus I80 all over 2i. So for us to prove this function, we have to introduce this. Sine 80 is the same as this. So instead of sine 80, we now write Laplace of exponential 80 minus exponential minus I80 all over 2i. So this is the formula for Laplace transform, true or false. F of t is this function. So integral 0 to infinity exponential minus st times the function, which is this. That is why you are seeing it here, the t. Look at it. Blaziz, are you okay? Okay. So far, so good. So now we need to multiply out this and apply indices here. So this will be equals to integral 0 to infinity. If we use this to multiply, we are going to have exponential, apply indices. When we apply this, we are going to have minus st plus I80, true or false. Then minus, use this to multiply this, exponential minus st plus minus, true or false. So minus times plus, here will be minus I80, then all over what? 2i, close the bracket, the what? The t. Abdulaziz, are you following? Hope you are following. Okay. Yeah. So let us proceed. Please, I want you to like. Let's proceed. So if you are following, let's proceed to consider this. Let us proceed to consider this. This is the same thing as integral 0 to infinity, then exponential. What is common here? T is common, true or false. Minus open bracket s minus ia close bracket t all over 2i the t, then minus integral 0 to infinity exponential minus open bracket s plus ia t dt. True or false? Okay, so I want to clean this up. Okay, so here will now be, we have to integrate this function and substitute the lower limit from upper limit, subtract the lower limit from upper limit. So if you can see what I am saying, mind you, this is a constant, we can factor it out. So let us integrate this function. So if we integrate this integral, we are going to have minus 1 all over 2I, right? Then times s minus ai, yeah, times s minus, ia, then okay, exponential minus open bracket s minus ia t at 0 to what? Infinity. Then this is 1, so you use this one to multiply this, is the same thing, so this one is not necessary. Then here is what? Minus, integrate this. Oh, sorry, something is missing here. You are supposed to put 2I, yeah. So when we integrate this, we are going to have 1 all over 2I, open bracket, s plus ia times exponential minus open bracket s plus ia t at 0 to infinity, true or false. But here we are supposed to have negative sign. After this negative, we are supposed to be minus, true or false. But if you use minus to multiply minus, it means here will be positive, isn't it? So let us write the plus at once. Here will be positive. So we want to substitute. Any question before I proceed? There is only 7 students that are available. Please, I want you guys to like, try and inform others to be here. It's okay. Yeah. Let's proceed. I want everybody to like. It's okay. Let's proceed. Let us proceed. Yeah. So if you can see what I am saying, this implies that anywhere we see t, we substitute in exponential, infinity. So here will be minus exponential minus open bracket s minus ia times infinity all over 2I open bracket s minus ia. True or false? Then minus, here we have minus the same thing, exponential minus open bracket s minus ia times 0, right? All over 2I open bracket s minus ia, then close bracket, what do we have here? Plus, right? Then the same thing applicable here. So, okay, let's proceed. Then here will be exponential minus open bracket s plus ia. Substitute in what? For all over 2I open bracket s plus ia. Then minus exponential minus open bracket s plus ia times 0, right? All over 2I open bracket s plus ia. Yeah. Hope you are following. Okay, let's proceed. If you can see what I am saying. So this implies that this implies that because of this infinity, all of this will be 0. So here is 0. And minus times minus, here will be plus. Then here will be raised to power 0. And anything raised to power 0 is what? 1 all over 2I open bracket s minus ia. Then plus here 2 will be 0. Then here will be minus, isn't it? Yeah. Here will be minus. Then here will be what? 0 raised to exponential raised to power 0, which is what? 1 all over 2I open bracket s plus ia. Right? So at this point we are going to look for the LCM. This is how it will be. 2I open bracket s ia minus 1 all over 2I open bracket s plus ia. Then this is equals to, we cross multiply this time this. So here will be 2I open bracket s plus ia, because this multiply this, minus open bracket 2I open bracket s minus ia close brackets, then all over this times this. So going to have 2I open bracket s minus ia close brackets times 2I open bracket s plus ia, then close the brackets. Hope I'm communicating. Look at the board. Look at the board. Look at the board. Any question? It's okay. So far, so good. What we need to do here is just minor arithmetic. I want to clean this up. Please make sure after the end of the video, the class, you copy the link to your media, paste it, and make sure you get the full notes. Okay, let's open these brackets. This is equals to 2I times s is 2is, and 2I times ia going to be 2ai squared, right? Then use this minus to open this bracket. Here will be minus 2is, then minus times minus plus 2ai squared, true or false. Then all over, open these brackets here, if we open this bracket, this time this 2is minus 2ai squared, right? This time this, then times, open this bracket, 2is plus 2ai squared. So let us, you don't need a prophet to tell you, right? This and this will go. Then we are going to have 2ai squared plus 2ai squared, right? Then this is all over, open this bracket, this times this, going to have 4i square s square, this times this, half plus 4, okay, 4a si cube, two of us. When you use this to multiply this, then use this to multiply this, you are going to have minus 4a si cube, then use this to multiply this, minus 4a square, or I raised to the power of 4. True or false? Am I right? Oh? Yeah. I'm right. Right? It's okay. So far, so good. I don't know whether there is any question. Is there any question? Why are we adding s? Are we adding s or subtracting? Glasses again. You say I should come again. Okay, let's look at it together here. Look at it now. This and this will cancel. We write this and this. Here is it. Use this to multiply this. You are going to have 2 times 2, 4. I times I square, s times s square. Then 2is to multiply this. You are going to have 2 times 2, 4. I times I square is I raised to power 3. Then we have as. The same thing applicable till you get to this point. Please take note. Let's proceed. Let's proceed. Okay, yeah. So if you can see what I am saying, we can add this to give us 4ai squared. Then all over this and this will go, 2 of us. So we'll be left with 4i squared s minus minus 4a square I raised to power 4. Okay, so at this point, I want us to go back to complex analysis. That is your first semester advanced algebra, right? You know very well that in advanced algebra, I is equals to square root of minus 1, right? then it means I square is equals to what? Minus 1. So if we are having I raised to power 4, this is the same thing as what? This is the same thing as what? Minus 1 times minus 1 to give us plus 1. True or false? Yeah, it's true. So if you can see what I am saying here, like here is minus what? Here we are going to have minus 1, right? Yeah, minus 1 times this is how it will be, 4a open bracket minus 1, then all over I square is minus, so 4 open bracket minus all in what? Raised to power 2, then minus 4a, then this is times 1, right? Okay, so if you can see what I'm saying, this is equals to this times this minus 4a all over. Here will be minus what? Minus 4 minus 4s square, then minus 4. Oh, I forgot, I want to forget about a square. Here is supposed to be a square times 1, right? Yeah, 4a square. True or false? So now look at the denominator. What is common? Something is common here. Is minus 4, right? So minus 4a all over, factor it out, minus 4 open brackets s square plus a square, right? So you can now see that we are there. Look at it. You don't need a prophet to tell you this and this will go. So therefore our final answer will now be a all over s square plus a square. This is how to prove this type of question. Any question? Or do you have any question? Please, I want you guys to like. No question? If there is no question, I'm going to drop assignment here. You will submit on Monday. You submit this assignment on Monday. You are going to submit this assignment on Monday. Before we proceed, I want to write down the assignment. Take it down. On Monday, I have class by 10:30. So I will come before 10:30 to collect my attendance. My assignment. So before we proceed, let me write down the assignment. 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 Given a function cos alpha at show otherwise, justify your claim that Laplace of cos alpha t s all over s square plus alpha square. So this is the assignment. This is the assignment. Given a function Laplace cos alpha t, show otherwise, justify your claim that this is equals to that. Okay, so we can now proceed to consider piecewise functions. Let us proceed to consider piecewise functions. Laplace transform. Okay. A piecewise function. Okay. And now claim piecewise function is okay. Let's find the Laplace transform of f of t defined as, example, find the Laplace transform of f of t defined as f of t equals to t all over k, comma 0 less than t less than k. Then here is 1. T is greater than k. Okay, so let us critically look at it together. Amen. Let us look at it together. Okay, let's proceed I want us to take note that, let's write solution. I want us to take note that a Laplace of f of t is equals to integral 0 to what? Infinity. True or false? Exponential minus st dot f of t dt. True or false? Right? Okay. But now in this function, this is 1 and this is another function. The function here is t all over k, then the function here is 1. True or false? So, and we have interval. So for that reason, this is how it will be. Our equals to integral, since the interval here is running from 0 to k, so our first function, look at the interval, running from 0 to what? K, right? So here is 0 to k, then f of t is t all over k times exponential minus st dt, then plus integral, here the function here is 1, true or false? Then the integral here, the interval here, t is greater than what? K. So it means the interval is running from k to what? Infinity. That is what it means. So k to what? Infinity. Then the function here is 1. So 1 times exponential minus st dt. Can you see now? So we want to integrate. So let's proceed, go ahead to integrate this function. This is equals to, this is k, right? So we can factor out k, 1 over k, sorry. This is the same thing as integral 0 to infinity of t exponential minus st dt, then plus 1 times this is the same thing, integral k to what? Infinity, 1 times this exponential minus st dt, right? Okay, we can integrate this function direct, but here we are going to use what is called what? Integration by parts, because we have two functions here. We have t, we have exponential what? True or false? So we have to apply integration by parts to obtain here. Then we now move down to consider this, and that will make us to obtain just here, we use integration by parts using by parts. I think we did that in class on Wednesday. So that is u dv is equals to uv minus integral v du, right? So inside this integral, you don't need a prophet to tell you. Now say let u be equals to t, and the v is equals to exponential minus st dt. So what we need to do, we have to differentiate this with respect to t. So if we differentiate u equals to t, we are going to have the u all over the t is equals to 1. Then cross multiply. It means our du will now be equals to what? 1 times dt is dt. Then integrate both sides. If you integrate the v, you are going to have v equals to, if you integrate exponential minus st, you are going to have minus exponential minus st all over s, right? Yeah. So any question here before I proceed? Oh, I should Janet Ola Yemi. I should come again. It's okay. I'll come again. Where? Please specify where. Janet, where? Where do you want me to come again? Okay, what I'm trying to say is this. Is nothing but, this is, we call it piecewise function. Piecewise. You are supposed to be taught in MD. Piecewise functions. Whenever you come across function of this one, it is known as what? Piecewise function. Is that clear? So what you see here is a function. What you see here is a function. So we have how many functions? 1, 2. Sometimes you have up to 4 to 3 functions. Is that clear? So you are going to use Laplace transform formula, but always be guided with the interval. They will give you the interval of each function. The interval here is running from 0 to what? K. Because t, we have t here. So that is the time is running from 0 to k. That is the first function. That is why you see, use this function to multiply this. Look at it. To give us this. Then the interval 0 to k, right? Plus the function here is 1. That is why I am saying it here. The interval, since it is greater than what? K. So the interval is between k to infinity, right? Okay. So as you can see now, plus k to what? Infinity exponential minus st dt. So when you come across functions, when you come across functions like this, amen. When you come across functions like this, we have t, we have exponential minus st. Note that this is we have 2 functions, so we are going to use what is called integration by parts. I think we did that on Wednesday. That is integration by parts is u dv equals to uv minus integral v du. This is the formula. So as it is, let u be equals to t, then dv, this your dv be equals to exponential minus st dt. That is why, can you see now? So at this point, you are going to differentiate this with respect to t. When you differentiate this, you are going to obtain 1. Then integrate both sides, this and this. If you integrate the v, you're supposed to have v. Then if you integrate exponential minus st dt, you're supposed to have minus exponential minus st all over s. Do you hear me? Do you understand? You can't see, I think the network is from your area. People cannot see the down well. This is serious. But it's clear from here. It is clear from here. It's clear. Okay. So it is clear from here. So let me clean the up. This up, down. We proceed. So if you can see what I am saying, here u dv, that is exponential 0 to what? Infinity. 0 to infinity t exponential minus st t is equals to, let's substitute in this. Our ordinary u is t, t times ordinary v is minus exponential minus st all over s at 0 to what? Infinity. Then minus integral, our du is dt, then ordinary v here is minus exponential minus s t all over s times du is what? Dt, right? Times dt. We have not come to this, so we just want to get this. Take note. So this is equals to, whole of this will be 0 because of the infinity sign and also the t here. By the time you substitute 0 here, you use it to multiply, all of this is 0. So what will happen here is 0 to infinity. This is 0 to infinity. It's 0 to k, sorry. This is 0 to k. Yeah, I think I made a mistake here. 0 to k, yeah. 0 to k. But mind you, there is 1 all over. Okay, let's write 1 all over k. This is 0 to k. Sorry, it is not infinity. I was expecting you to correct me. 0 to k. Yeah. So we have to substitute in the k. Yeah. So when we substitute in the k, yeah, we are going to have k times, okay, here will be minus, right? Minus k times exponential minus sk all over s, then minus, open bracket, already we have minus here, minus, you substitute in the 0, 0 times exponential minus s 0 all over, yeah, then minus times minus plus integral 0 to k exponential minus st all over s times dt. So because of this 0, all of this will be 0, right? So far so good. So here now, all of this will be 0. So here will now be k times minus k times minus sk all over s. This is 0 plus, let us integrate this. If we integrate this, we are going to have minus exponential minus st all over s times s at 0 to what? K, right? Yeah. So this will give us minus k exponential minus sk all over s. So here we are going to have this time this minus open brackets, okay, 1, let's do it this way, minus 1 all over s, because s times s square, open bracket, exponential minus sk, you substitute in the k instead of then minus exponential what? Minus s open bracket 0, right? Close the bracket. So far so good. This is equals to minus k exponential minus sk all over s, then minus 1 all over s square open bracket exponential minus sk, then here will be what? 0. Everything raised to power 0 is what? Minus 1. Yeah. Then let us not forget that we can now take off this. Let us not forget that there is what? 1 all over k multiplying all of this. So far so good. This will now be, it means this one give us this answer. Is that clear? So we write this down, 1 all over k open bracket minus k all over s exponential minus sk, then minus exponential minus sk all over s square multiply minus 1 all over s square times minus 1 plus 1 all over s square. Then plus, let us integrate this. Yeah. Let us integrate this. When we integrate this, we are going to have open bracket minus exponential minus st all over s at k to infinity, right? Yeah, at k to infinity. Any question, please? K to infinity. So this means that we have to subtract the lower limit from the upper limit. So when we do that, this is what we are supposed to have. When we do that, this will now be 1 all over k open brackets minus k all over s exponential minus sk minus exponential minus sk all over s square, then plus 1 all over s square, then plus open brackets Subtract the lower limit from upper limit, minus exponential minus s, open brackets, infinity, all over s, then minus exponential minus sk, all over s, close bracket, close bracket. So this is equals to 1 all over k, open bracket, minus k all over s, exponential minus sk, minus exponential minus sk, all over s, plus 1 all over sk, then minus times plus minus, all of this will be 0, true or false, because of this infinity. So this times this plus, here will be plus exponential minus sk all over s. Yeah, so far so good. I think this is how you are going to solve this type of question. I know it takes us time, but because I'm teaching you, that is why. Is that clear? But if you know what we are doing here, I don't think it's difficult. We are just applying the Laplace transform, the properties here to integrate anything we are integrating. Is there any question? No question. There is no question. I'm going to drop another assignment, making it two assignments. Is that clear? So I'm going to drop another assignment. Yeah. Got the answer. So I want to drop another assignment here. Let me claim this. Another assignment, take note, Monday, collecting them. Monday, collecting them. Okay, assignment. Find the Laplace transform of the function. Find the Laplace transform of the function f of t is equals to t minus 1, comma, the interval 1 to 2, then 3 minus t, comma, 2 less than t less than 3. Very good assignment. You play with it and it is very important. Yeah, Troy. US 10,000, US 100,000. Where are you watching from? Troy. Which country? Troy, which country are you watching from? Kenya. Oh, you're welcome. That is lovely. Nice meeting you. You're watching from Kenya. Hope you are following what I'm solving here. I'm solving from Nigeria. Nice to meet with you too. Oh, you're understanding. That is nice. I love that. Yeah, I'm solving from Nigeria, Kaduna City. Kaduna. Have you heard of Kaduna Polytechnic? The largest polytechnic in the Africa. That is where I'm solving from. Yeah. That is lovely. Troy, nice meeting you here. I will drop my WhatsApp number here so that we can chat. Is that clear? In case you have any difficulty in mathematics, I'll help you out. Is that clear? Troy, yeah, this is my WhatsApp number. +2347033667737. You can reach out to me on this number, either call or WhatsApp. Is that clear? Troy, have you gotten the number? Yeah, I'll be grateful if you do that. Try and chat me up, then we communicate. Is that clear? It's okay. Gentlemen and ladies, we are going to call it a day. Please don't forget to like and share. I'll be very grateful. Thank you and God bless you guys. See you on Wednesday. Bye. Have a wonderful bed rest. Love you guys. Bye. Yeah. Troy, bye.